Hello everyone. In this video we are going to solve question number 20 of Q28 physics paper. The question from mathematical physics and says that given the recurrence relation for the legendary polynomials 2n plus 1 x times p n x is equal to n plus 1 p n plus 1 x plus n times p n minus 1 x, which one of the following integrals has a non-zero value? So this is a question which is a special kind of second order linear differential equation which is called the legendary equations. So to start with, let me give you a brief introduction of what are legendary equations. So, second order linear differential equations of the given form d2i by dx square minus 2x dy by dx plus n times n plus 1 y is equal to 0. So whenever you have this kind of function, second order linear differential equation, and these kind of differential equations are called the second order linear differential equations, or called the legendary equations, called the Legendre's equation. And they have a general kind of solution of this kind: a, p and x, the solution of this legendary equations, and b times q and x, where this p and x are called legendary polynomials of order n. Okay, and so in order to solve this question, you need to have some properties which are very important related to the legendary polynomials. First is orthogonality property, that is integral minus 1 to 1 p n x p m x dx is equal to some constant times canonical delta function del mn, that is which is equal to 0 for m not equal to n and is equal to 1 for m is equal to n. The second property is if m is equal to n, then this will become p n x square whole square dx, and which will be equal to 2 upon 2n plus 1, and delta mn will be 1 because it is delta nn, which is equal to 2 upon 2n plus 1. So which is how you will solve this. So these two properties are very crucial for solving any questions which comes in GATE exam related to legendary equations. And then there is another property which is minus 1 to 1 x to the power m p n x dx is equal to 0 for m less than n. So these two properties are very important. So in this given question, they have we have to find out which one of the following has a non-zero integral given this recurrence relation. So if we'll take the first question, that is first example, minus 1 to 1 case 1 minus 1 to 1 x square p n x p n plus 1 x dx. Now you have this recurrence relation, so you will just break this integral such that you get this form, x p n x form. So what you will do is that you can write this as in this form: minus 1 to 1 x times p n x dx p n x, and x times p n plus 1 x dx. So you have just written, you break this in this form, and now you will just replace x p n x with this relation. X p n is nothing but this upon 2n plus 1. So it will become n plus 1 p of n plus 1 of x upon 2n plus 1 plus n Pn minus 1 of x upon 2n plus 1. Similarly, the quantity in the second square bracket can also be written as, here your n will be replaced by n plus 1, so you just replace n with n plus 1, so it will become n plus 2 Pn plus 2 of x. 2 of n will become, here will, in place of f you write 2 of n plus 1, so it will become 2n plus 3. Similarly, just replace n with n plus 1, so n plus 1, p of n plus 1 minus 1 will be n, and this will be 2n plus 3. Now you just do the cross, you get four products. First you will multiply Pn plus 1 with Pn plus 2, and using this orthogonality property, you know that if n is not equal to m, then it will be 0. Here you say that in all the 4 cases Pn plus 1 is and Pn plus 2, these two indices are not same, so this product will be equal to 0. Similarly, Pn plus 1 into Pn will also be 0. Pn minus 1 into Pn plus 2 will also be 0, and Pn minus 1 times Pn will also be 0, because none of the indices, because all these indices correspond to when both the indices are not same, they are different. Therefore, this integral will turn out to be 0. Similarly, if you look for the third option, then also if you just solve it, you will find that it will come out to be 0. Okay, and similarly, if you solve, for example, third option. Okay, let us solve third option. In third option, it is x pnx square minus 1 to 1 x pnx square dx. This can also be written as minus 1 to 1 x times pnx times of pnx dx. X times pnx can be expanded as same function which I have written, n plus 1 p of n plus 1 x upon 2n plus 1 plus n p of n minus 1 x upon 2n plus 1, this times p of nx dx. Now you just do multiplication, pn plus 1 times pnx will be 0, and similarly pn minus 1 pnx will be 0, because these indices are not different. It is n minus 1 here, n here, they are different, so it is 0. N plus 1 here, n here, so they are different, so equal to 0. So this will also be 0. Now let's look at third option. Okay, so third option is minus 1 to 1 x square pnx pn plus 2x. So it is x square pnx pn plus 2 x dx. So when you will solve this, you can break this as minus 1 x times pnx dx times x times pn plus 2 x dx. Now you can just use that property, and then you can simplify it as n plus 1 p of n plus 1 x upon 2n plus 1 plus n of p n minus 1 of x upon 2n plus 1. Sorry, there will be only one dx. Similarly, second equation can also be written as n plus 3 p, you just write in place of n plus 2, so it will become pn plus 4, if I'm not wrong. So you're just replacing n with n plus 2, so yeah, it will become n plus 3 x, and this will become 2n plus 4 plus 1, that is 2n plus 5, plus n plus 2 p n plus 2 minus 1, which is n plus 1 x upon 2n plus 1 5. Now you again do product. No, you find that pn plus 1 times pn plus 3 will be 0, pn plus 1 times p. Okay, so you get one term, minus 1 to 1 n plus 1 n plus 2 upon 2n plus 1 2n plus 5 times pn plus 1 x whole square dx. This term will be 0 and this term will also be 0. So you just solve this and it will become, using this property, Pn x square dx is nothing but 2 upon 2n plus 1 dx. So you will have, if you just take this out of this and consider some constant c of n, and you just this p minus 1 to n, p of n plus 1 x square dx. So this will be nothing but, since here is p n plus 1 is there, so it will be c of n times 2 upon, here it was n, therefore 2n plus 1, here it is n plus 1, so 2 of n plus 1 plus 1, which is cn times 2 of 2n plus 3, which is not equal to 0. So this d integral is not equal to 0. So the correct option for this question is D. D is the right option. So thank you for watching this video.